In today's lesson, we'll be learning about first and second differences. Let's talk about linear relations. If you recall, a linear relation looks like a straight line. In a linear relation, the first differences are the same. A quadratic relation looks like a curved line. We use the word parabola to describe this. In a quadratic relation, first differences are not the same, whereas the second differences are the same. We're going to be seeing these patterns today. In our first example, we're going to be looking at a linear relation, y equals 2x minus 5. If you recall, this line is in slope-intercept form. Which is y equals mx plus b, where m is the slope and b is the y-intercept. Therefore, 2 would be our slope and negative 5 would be our y-intercept. As you can see, we have a table of values. We have a series of x values, but we do not have their corresponding y values. But we can find these y values by substituting in these x values into our equation. So we're going to take these x values and we're going to substitute them into y equals 2x minus 5, which will give us our y values. So let's do that in this chart. I'm just going to zoom in to create more space to write. And let's start substituting in these x values. So I have 2 multiplied by negative 2 minus 5. Let's simplify this. 2 multiplied by negative 2 is negative 4. Then subtract 5 stays exactly the same, and negative 4 subtract 5 is negative 9. We're going to repeat these steps for the other values of x. 2 multiplied by negative 1, subtract 5. That simplifies to negative 2 subtract 5, which is equal to negative 7. Let's repeat that again. 2 multiplied by 0, subtract 5. Anything multiplied by 0 is 0. The subtract 5 stays exactly the same, which leaves us negative 5. 2 multiplied by positive 1, subtract 5. 2 times 1 is 2. Subtract 5 stays the same. 2 subtract 5, be careful here, is negative 3. And last but not least, we have 2 multiplied by 2, subtract 5. 2 times 2 is 4. And 4 subtract 5 is equal to, be careful, negative 1. The next step is to calculate the first differences. So let's do that over here. What you're going to do is you're going to be using these y values. Okay, and I'm just going to make these little lines to help you visualize what's going on. So what I start with is negative 7 subtract negative 9. Remember, when you have two negative signs beside each other, that is positive. So negative 7 plus 9 is 2. We're going to do the exact same thing here. Negative 5 subtract the previous number, which is negative 7. When you have two negative signs, that becomes positive. So negative 5 plus 7 is 2. We're going to do the exact same thing down here. Negative 3 subtract the previous number, which is negative 5. But when you have two negatives together, that becomes positive. So what you really have here is negative 3 plus 5, which is, again, equal to 2. And last but not least, I have negative 1, and I'm going to subtract the previous number, which is negative 3. So when you have two negatives together, that becomes a positive, and negative 1 plus 3 is 2. Therefore, you can see that the first differences are all the same for linear relations. In our second example, we're going to look at a quadratic relation, which is y equals x squared minus 4. How do I know that it's a quadratic relation? Well, if you look at the variable of x, it has an exponent of 2. And that is a giveaway that it is a quadratic relation. We're going to be doing the exact same thing as our previous example. We have a series of x values, but we do not know their corresponding y values. But we can substitute these values of x into our equation to solve for our y values. And let's go ahead and do that. I'm just going to zoom in so we can see everything more clearer. Instead of writing x, we're going to write the number in brackets. So I'm going to start with -2 to the power of 2 minus 4. Let's simplify that a little bit. -2 multiplied by itself is +4. And +4 subtract 4 is equal to 0. Where did I get that subtract 4 from? Well, the subtract 4 stays exactly the same from the previous step. Let's do this again. I want to square -1 and subtract 4 from that. Well, -1 multiplied by itself is +1, and +1 subtract 4, be careful here, that is equal to -3. Let's do this again. 0 to the power of 2 subtract 4. 0 multiplied by itself is 0. The -4, or subtract 4, stays exactly the same, which leaves us -4. Let's do this again down here. +1 squared minus 4. 1 multiplied by itself is 1. 1 minus 4, be careful, is -3. And last but not least, I have 2 squared minus 4. 2 multiplied by itself is 4. 4 subtract 4 is equal to 0. And last, I'm just going to zoom out to show you all the work that was needed for this step. In this second part of our second example, I'm going to start by rewriting the y values we just calculated. So that was 0, this was -3, this was -4, this was -3, and this was 0. Just like our previous example, we are going to calculate the first differences. So let's go ahead and do that. I'm going to make a little note for myself so I don't get confused. So I'm going to start with -3, and I'm going to subtract 0. -3 subtract 0 is -3. Over here, I'm going to take -4. I'm going to subtract the previous number, which was -3. When you have two negative signs together, that becomes positive. So -4 plus 3, be careful here, is -1. And over here, we have -3, and you're going to subtract the previous number, which was -4. Again, when you have two negatives together, that becomes positive. And what you have here is -3 plus 4, which is +1. And last but not least, I have 0, and I'm going to subtract the previous number, which is -3. When you have two negatives together, that becomes positive. So 0 plus 3 is 3. All right, now let's calculate our second differences. We're going to do the exact same method. So let's do that over here. So I'm going to make a little note for myself with these red lines, just to help myself visualize what's going on. Here I have -1. I'm going to subtract the previous number, which is -3. When you have two negative signs together, that becomes positive. So -1 plus 3, be careful here, is +2. Let's do the same thing here. +1 subtract -1. Well, when you have two negatives together, that becomes positive. So 1 plus 1 is 2. And over here, we have 3 subtract 1. That's pretty simple. That's also equal to 2. As you can see, the second differences of a quadratic relation are the same, but the first differences are not the same. And that is the pattern I told you in the beginning of this lesson.